Good afternoon, children. Today we are starting with the chapter Types of Rocks. Rocks are all around us. We see them on the streets, roads, field, playground, kitchen, garden. Every building around us is made up of rocks. Even the pencil lead, the chalk, the bricks that we see all around us are all forms of rocks. Any natural mass of matter that makes up the Earth's crust is called a rock. That means sand and mud are also parts of rock. Our entire planet is made up of rocks. So rocks are of different shapes and colors. And we can define them as a combination of different kinds of minerals. They occur in various texture, shape, and color. So we understand that the mineral content of them inside them gives the various shapes or the colors to the rocks. So we have understood that the top layer or the lithosphere is the surface of the earth, which is made up of solid rock and soil. But the land surface that is not covered, that is, it is not submerged underwater, is also very less. That is, it is only 29% of the total surface of the earth, which comprises of the continents and the islands on which we live. Let us now revise the meaning and the names of the continents. What is a continent? Continents are large land masses on the surface of the earth that are surrounded, or you may say usually separated from each other by vast water bodies called oceans. Let's recall the names of the continents. They are Asia, Africa, North America, South America, Antarctica, Europe, and Australia. And all these continents are a part of the lithosphere or the outermost crust of the earth. Now we need to understand the word crust in detail. To understand that, first we must primarily understand that the earth is made up of several concentric layers, exactly like an onion or a boiled egg. When we slice them, we see layers. Similarly, the earth is also divided into layers. You see three layers. The topmost one, that is the shell, then the white layer, and then the yellow or the yolk layer. But exactly like that, there are layers inside the earth. But how were they formed? It was not like this since the very beginning. It all started 4.5 billion years ago when the earth was revolving and rotating around the earth exactly in nothing but a molten materials. It was just a round ball of molten materials which were revolving around the sun. As the liquids slowly cool down, the denser or the heavier materials that form the Earth's interior now, they all solidified and sank to the center of the Earth and formed a metallic core. Core, that is the centermost area. Exactly like when you put a spoonful of sugar in a glass of water and it sinks down because of its high density and heavy weight. Similarly, the heavier materials which are now in the core, like the iron and nickel, all sank to the center of the earth. The denser elements were pushed down towards the interior, where they formed the interior or the core of the earth. And the less denser materials or the elements were all pushed upwards. And this led to the formation of the earth with several different layers of materials, namely the crust, mantle, and the core. The crust can be divided into two parts. The upper layer is made up of Cl, Si and Al, the two elements. Si is the symbol of silica and Al is the symbol of aluminium, the lightest metal in the upper layer. The lower layer is made of Si and Ma or Sima, that is silica, and magnesium. Again, Si is the symbol of silica and Ma is the symbol of magnesium. The thickness of the crust varies from 8 to 50 kilometers, that is the continents, which is leading towards the ocean floor. And then we have the average density, which is between 2.7 and 3. Having a look at this diagram, we can see the composition of the crust or the lithosphere. We see that the two layers, number one, the Sial and the Sima, which has, number one has the continents that you can see they are submerging into the sea level area, which is the Sial is the continent area and Sima is the sea floor. So we can easily see that the first layer, which is the Sial, forms the continents while Sima makes up the ocean floors. Let us now learn the characteristics of the mantle. The mantle is semi-solid. It is rich in iron and magnesium. Its thickness is about 2,850 kilometers and the average density is between 3.5 and 5.5.
Rocks and water bodies. But what about the inside of the Earth? If we were to take a look at the Earth's interior, we would see that the Earth consists of 4 layers. They are the crust, the mantle, the outer core, and the inner core. The crust is the outermost layer of the Earth. It consists of various landforms like mountains, plateaus, volcanoes, etc. The crust also consists of numerous rock plates. The shifting of these plates resulted in the formation of continents. In reality, the crust of the Earth is a very thin layer. It is only 50 kilometers deep. The crust floats on top of the outer layers of the Earth. The oceanic crust is thinner than the continental crust. The mantle forms the main mass of the Earth. It is the layer just under the crust. It extends from Moho's discontinuity to a depth of about 2,900 kilometers. The mantle is a partly molten layer and can have temperatures reaching to 4,000 degrees Celsius.
Hi everyone. In this video, we're going to be talking about minerals. So let's get started. What are minerals anyway? Well, in the simplest sense of the term, minerals are the building blocks of rocks. Here's a rock. This is a piece of the igneous rock called granite. If you look carefully at this chunk of granite, you'll see all sorts of speckles of gray and white and black. And if you zoom in, you'll see that these are actually crystals, mineral crystals. This particular piece of granite has the mineral quartz, biotite mica, and plagioclase feldspar. We'll study these in more detail later on. So, on Earth, there are over 2,000 varieties of minerals, some of which are seen here. As you can tell, they come in a wide variety of colors, shapes, sizes, textures, and all sorts of different physical characteristics. Minerals have quite a few uses in our everyday life. Just to give you an example, this here is a rough, uncut diamond. Of course, we use diamonds for jewelry. We also use diamonds in construction applications, as the tips of saw blades, and a variety of other industrial uses. Here's another mineral. This is called fluorite, most famous for its inclusion in toothpaste. Yes, when you see the name fluoride on a toothpaste, that means it's made out of the mineral fluorite. But what else are minerals used for? Well, this here is talc. Talc is a very common mineral that is ground into a fine powder. It's very soft, and it's used in baby powder. Sometimes you might hear it referred to as talcum powder.
Rocks are classified in several ways, but important classification is done on the basis of their origin. The three main types of rocks based on origin are igneous, sedimentary, and metamorphic rocks. We will study all of them in detail one by one. The word igneous or the igneous rocks is derived from a Latin word ignis, meaning fire. These rocks were formed due to cooling, solidification, and then crystallization of the hot molten materials of the earth known as magma. Now, magma is found at the great depths in the interior of the earth. When this magma flows out onto the earth's surface, it is known as lava. Now, since the igneous rocks were the first to be formed, they are called primary rocks. They form the basis or the formation of all the other types of rocks. Let us understand the characteristics of the igneous rocks. They are hard and compact. They are granular and crystalline. We will do all of this in detail. They are formed by solidification of molten magma, and they do not occur in layers or strata. The igneous rocks, as we discussed, were formed due to the cooling, solidification and crystallization of the molten material of the earth known as magma. Now this magma, when it reaches and flows onto the surface of the earth, it is known as lava. And if the cooling and solidification is taking place at some depth, that means inside the earth or within the earth, it is forming a different type of rock. And if it is forming or it is cooling and solidifying at the surface, then it is forming another type of rock. So the types of rocks are on the basis of their origin, that is intrusive igneous rocks and extrusive igneous rocks, and on the basis of the chemical composition, that means what chemical do they contain, whether it is acidic or whether it is basic. They are termed as acidic igneous rocks or basic igneous rocks. So here we have a very beautiful table in very short pointers to make you understand that on the basis of the origin, you have intrusive or plutonic. Now this word I will explain a little later. And then we have extrusive or volcanic. Now here first let us understand the difference between the two. Then we'll understand the meaning of these two extra added words. Cooling takes place slowly in the inside. Why? Because it is inside the earth's surface, so automatically anything which is inside or covered up, it will not cool down as quickly as possible, which is anything left on the surface will cool down faster. And in the extrusive, that means on top of the earth's surface, the cooling takes place much quicker. In the intrusive one, you have the large crystal formation because the cooling is very gradually happening. Therefore, the crystals are large. And the small crystals are formed in the extrusive because the cooling is happening very fast. Example is granite here, and the example is basalt here. Of extrusive is basalt, intrusive it is granite. We will be using the same examples to understand the second category of igneous rocks. So please keep in mind these examples. Now coming back to the name that I had said that we will be discussing, the intrusive rocks are also called plutonic rocks as they are named after the Greek god of the underworld, Pluto. Now let us start with the next PPT. As we have revised, igneous rocks, they have two subdivisions, one on the basis of origin, that is intrusive and extrusive igneous rocks, and on the basis of chemical composition, forming acidic and basic igneous rocks. Now you can see the pictures of basalt and granite here, so that you can easily understand clearly that granite has large crystals as the magma cools below the surface of the earth, and the process of solidification takes place slowly, leading to the formation of very large or comparatively large crystals. And the reverse happens in basalt as it is an extrusive igneous rocks. Now we shall learn about the sedimentary rocks. Sedimentary rocks are formed from sediments accumulated or deposited over a large period in seas, lakes, streams, rivers, and oceans. Here we need to understand that this solidification is happening in layers. So one layer on top of the other is added, and due to their own weight from above, the sediments get compacted and cemented together to form sedimentary rocks. Now here we need to understand the two words cementation and compaction in detail. But before that, let us understand the characteristics of the sedimentary rocks. Number one, these rocks are found in layers or strata. So they're also called stratified rocks as they are formed by the deposits of sediments. What are sediments? Sediments are smaller pieces of rocks or materials derived from other rocks. Now, which are the other rocks? They might be the igneous rocks or the metamorphic rocks. Number two, these rocks may contain fossil, that is, the remains of the dead animals and plants. Here are some images of the mechanically formed sedimentary rocks in which you can see the layers. In this process, the sediments are gradually squeezed by the weight of the overlying sediments to form the rocks, and since such rocks are formed in layers, they are known as stratified rocks. You can see each rock has so many layers. The next slide also shows you a lot of layering which has happened through ages, and some of the examples of all types of sedimentary rocks are limestone, chalk, calcite and dolomite. Organically formed sedimentary rocks may contain fossil, and here these rocks are formed by the deposition of shells and skeletons of all the sea organisms, that is the coral, clams, oyster. These live on the ocean floor only, and they extract the calcium carbonate from the ocean water. So chalk and limestone are the best examples of such rock type. In the next slide also you can see the remains of dead animals and plants very precisely in each one of them. And this diagram shows you how on top of a dead animal you can see the layering of the sediments which has taken place, thereby burying the dead animal inside or in between the layers of the rock. The next slide shows us chemically formed sedimentary rocks, examples of which are rock salt, dolomite, and the best example of it is gypsum. But before we go to gypsum, let us see the potash which is extracted from the mine exactly like the coal. You can see the entire layer of potash. Now this is the same potash which is extracted and used. And this is the rock salt which we commonly use in our houses, also known as the senda namak. And this your moms must be using in house, especially for fasting, etc. Now coming back to gypsum, the gypsum actually is the best one out of these rocks which is mostly used, and it is a mineral found in many items that we are using nowadays, like manufacturing of the wallboard, cement plaster, toothpaste and shampoo. It has a very good binding quality or an ability, because of which it is being used in so many products. And you must have seen in your own school also, if not in the house, you have the false ceiling. It is basically made of gypsum only. To understand cementation and compaction, let us start. When the igneous rocks are exposed on the surface of the earth, they are broken into bits and pieces. They're of all sizes and they are broken by the agents like wind and water. Now, these smaller pieces of rocks are known as sediments, which are usually transported by the running water and they are deposited in the layers at the bottom of lake, sea, river, and ocean. Now, these layers of sediment they turn into rock through the two processes. Number one, compaction, and number two, cementation. What is compaction? Compaction is the slow squeezing of sediments to form hard rock. Example, when the sand is compacted, it forms sandstones. And cementation is the binding together of the compacted cement. Now you have already pressed the layers together, you have compressed them and compacted them, but then you need to cement them together or glue them together. Now there are certain materials like calcium carbon compounds which are carried by the water, and in between the spaces of these sediments they just fill the spaces around the pieces of the sediments and glue them together to form rocks. Examples are calcite and silica. You need to understand this process in detail. Here is a picture that these are the loosely packed particles or sediments and water has filled up the space in between. Now, as I said, the water is carrying your calcium compounds which are going to glue them together. So here the cementation is going to happen. Gradually the cementation material fills the entire pore spaces and the grains are bind together or cemented together, forming an entire rock. The next picture also shows you the same compaction. You have sediments, water is there, it is squeezed out, and then the cementation takes place through the agents of calcium compounds. Metamorphic rocks. Now, metamorphic rocks are those rocks which are formed by the metamorphism of pre-existing rocks due to high temperature and pressure or both applied together. Now, the high temperature is from the hot magma which is inside the earth, and the pressure because of the movement of the earth, that is the folding and the faulting, all give a lot of pull and compression onto the layers of the earth. The word metamorphic is derived from the word metamorphose, which means change in form. And we all know this word when we understand that the caterpillar goes through metamorphosis and turns into a butterfly. So here the metamorphic rocks are those rocks which have changed and become different rocks due to the influence of high temperature. For example, slate is formed from clay and graphite is formed from coal, and the heat is, as I said, it is from the hot magma and from the friction of the moving rock layers. So heat can also be from two areas. Here we have a few examples. The table of the metamorphic rock, that is the limestone changes into marble, sandstone changes into quartzite, shale changes into slate, coal changes into graphite, and the best known one is the graphite again transforms itself into diamond. Basalt changes to schist. Granite we have nice, this is pronounced as nice. The G is silent. Dolomite changes into marble, becomes a lot more harder than it was previously. Let us now understand the significance or the importance of rocks. Here we have the formation of soil, which is the source of all life, the plant life, animal life. We all only survive because we have the nutrient soil to supply us food. The next point is the rocks provide raw material for mineral based industries because they have minerals. Those are all mineral ores which have the iron, copper, magnesium, you name it, and the rocks are the basic source from which we achieve them. Rocks provide raw material for the construction industries also. Marble slabs for flooring, gypsum for making cement. We have already discussed all these uses. And rocks are a source of precious metals and gemstones. We all like to wear diamonds, right? We have seen the gold and silver jewelry. We love to wear it. We have the diamond, sapphire, ruby. All these are gemstones. Now, what are stones? These are rocks only. So here we come to the end of the chapter. Let us now discuss the homework for today. How are sedimentary rocks formed? That is the first question. Question number 2, draw the table of types of sedimentary rocks. It is given on the slide 11. No confusion with that question. The next question is, what are metamorphic rocks? Very simply, just the definition has to be written. And number 4, classify the rocks according to, these are the examples which have been given. Now you have to classify them. Example, I have just given one as a answer, that is granite is an igneous rock. Simply you just have to write in front of these what type of a rock or which family do they belong to. The last one is state the importance of rocks, which we just discussed. You only have to write 2 points. Thank you, children.